Now we have a situation where we have a horizontal pipe and water in one part of the pipe moves at 2 meters per second, in another it moves at 8 meters per second. We want to know what the change in pressure is between the 2 points. Now, in a horizontal pipe, there's no change in y, the vertical coordinate. So when we look at Bernoulli's equation, which says that 1/2 rho v squared plus rho gy plus p is constant, that tells us that rho gy is constant. It's not going to change. However, we do have a change in velocity, and the velocity is going to increase from 2 meters per second to 8 meters per second. Now, from what we saw immediately before, that tells us that our pressure is going to have to decrease. This goes up, this, which doesn't change, so just this plus this has to be constant. If this goes up, this has to go down. So what we have now is 1/2 rho v squared plus p is constant. Since y doesn't change, we say that since y is constant. Now, if 1/2 rho v squared plus p equals constant, that means the change in 1/2 rho v squared plus the change in p has to equal what? Well, if this plus this is always the same, then whatever the change is here, the change in here has to be equal and opposite. The changes have to add up to 0. So the change in this quantity plus the change in this quantity is 0. So the change in pressure is equal to negative the change in 1/2 rho v squared. Now, rho, this is presumably water. I think we state that it's water and has density of 1,000 kilograms per cubic meter. And of course you might, well, get a problem that has mercury flowing with a density of 13,600 kilograms per cubic meter, or some other liquid with a density that varies from 1,000 kilograms per cubic meter. So that's easy enough to handle. That's just whatever the density is, that's what you plug in here. Okay, so what's the change in 1/2 rho v squared? From here to here. Well, the change from here to here is the value here minus the value here. So I'm going to say that's 1/2 of 1,000 kilograms per cubic meter times 8 meters per second quantity squared minus the same thing, but now we have the writing a little smaller here because you know what I'm going to write. 1,000 kilograms per cubic meter times what? Times the 2 meters per second we have here. Okay, well, if we calculate that, 8 squared is 32, half of that is 16, so we get 16,000 whatever kilograms per cubic meter times the square of meters per second gives us. And we'll work that out in a second. Actually, I'm just going to assert it, and then I'll maybe make a little note in this blank space here. So we're going to have 16,000 of whatever our units multiply out to be. And here we're going to have what? That's 4 times 1,000, that's 4,000. Half of that is 2,000. That's going to leave us 14,000. So that's 14,000. And it's going to turn out that that's newtons per square meter. I'll fill that in over here, make sure we understand that. So the delta P is negative the change in 1/2 rho v squared, and that's going to be negative 14,000 newtons per square meter. We could also call that 14,000 pascals. Now, why is the unit newtons per square meter? Because this is pretty important. Well, let's go over here. Kilogram over meter cubed times the square of meter per second is what? That's kilograms over meters cubed multiplied by meters squared over seconds squared. Now, in the straightforward unit calculation, that comes out kilograms over meter second squared. The meter squared divides a meter cubed, leaving you a meter in the denominator. But I'm going to choose to rearrange this as follows. I'm going to take the kilogram and I'm going to take the meter per second squared, take one of these meters of the meter squared here, and I'm going to say that that gives us kilograms times meter over second squared. But I've still got a meter left out of this meter squared, which is going to have to divide into this meter cubed. So that gives me kilogram meter squared, kilogram meters per second squared divided by meter squared. But a kilogram meter per second squared is just a Newton, so that's your Newton per meter squared.